Hi, this is Margo. This is Sunday afternoon, August the 2nd, 2020. I hope everyone is doing as well as possible. I would like to welcome all of my subscribers over on YouTube. I think I've gotten a bunch of new subscribers, and so welcome, and hope you enjoy the channel. And welcome to my members on Subscribestar. If you like what I do over here on my weekly updates on YouTube and you want to see more, I recommend you check out my Subscribestar page, and I do almost daily updates for my members over there, and I do posts every day, and it's a good way to keep up with the methane. I report on the methane as soon as it becomes available from NOAA and from CAMS, and I'm reporting on the sea ice and earthquakes and other related climate things as we come into these end times. I also follow sulfur dioxide quite closely, and I think that's a big player in what's going on with the earthquakes and what's going on with the planet. So this is my weekly update that I'll post on YouTube. I've been following the NOAA methane data for the 477/469 millibar reading since March of last year, and so we're seeing a definite increase, and it goes in a cycle, and we're in the warming cycle now. We will be in the warming cycle until about mid-October, and then it'll go down. So or the rising cycle. So here is the Met-1 satellite for yesterday, August the 1st, for the morning. The mean or average was 1902 parts per billion. The high reading was 2408. This high reading is signified by the pink color. You can see this pink all the way around the globe. Now this millibar reading is about halfway up in the atmosphere. It's almost 500 millibars. So it's a range. This is a range between 2000 and whatever is the high reading on each of the pictures here. So 2408 in this case. In the afternoon, the Met-1 satellite, the mean was 1901 and the high reading was 2361. On the Met-2 satellite in the morning, the mean was 1881, the high reading was 2358, and in the afternoon the mean was 1883 and the high reading was 2391. So here's the spreadsheet and chart that I've been working on. Here's for August the 1st, and here are all the numbers I just called off, added up and divided by 4. So the average for this layer is 1891.75 parts per billion. So that's showing a large increase over last Saturday of 4 parts per billion. So here's the chart, and we can see the line here going up. And last week when I put this chart on, it added this next 10 points because they figured, I guess the AI figured we were going to be going into the next 10 points. And we passed the highest from last year. We passed that several weeks ago. It was on October the 12th, 1885, 0.75 right there. So we passed that on when I did the weekly report for July 11th. So here we are. So now we're headed up. So we've seen since February 29th of this year, we've seen an increase of 15.25 parts per billion. And since March 1st of the 2019, we've seen an increase of 34.5 parts per billion. Now, just to show you what's gone on a daily basis, I recently started charting methane daily, and this is included in my daily reports for my Subscribe members. So here it was last Saturday on the 25th at 1887.75. Then on Sunday it went down another 0.25. On Monday it went up 0.25. On Tuesday it went up 1.25. Wednesday it went up 0.75. Thursday it went up 0.25. Friday it went up 0.5, and then Saturday it went up 1.25 this is parts per billion over the day before. And so this is the weekly change. And so since last Saturday, here it is at 4 parts per billion higher in 1 week. So that's a steep rise. And since February the 8th of this year, we've seen an increase of 28.5 parts per billion. So we can see that methane is really taken off. We're in no man's land. We're in uncharted territory where it's never been this high since humans have been recording it. And it's changing the weather, it's heating up the atmosphere, and it's changing the weather in the Arctic, and you know, there's more rain, and it's just changing a lot of things. So there's that. Another thing that happened this week. Now this graph is from, or this picture is from July the 30th. So that was, what day was that? That was Thursday. We saw a spike. This was the Met-1 satellite. In the afternoon, I did report on this on my Subscribe page. Methane spiked to a high of 2933 parts per billion. So that's almost 3,000 parts per billion. It's spiked out there, and we don't know where it happened, but you know, I figure someone like Sam Carana, who has the inside scoop on everything, can pinpoint the place that it happened and let us know. So so there's that. Now let's run the methane movies over here on cams. This is Copernicus Atmosphere Monitoring Service, and they just released their Sunday data for today. I have the Arctic view pulled up and surface level ready. Here's the color ledger at the bottom. And so the data is for today, and then the forecast period down here runs Monday through Thursday, and their forecasts are pretty accurate, but every time it's updated, I do a new report. So here's where it left off on Saturday. We've been seeing this high release continuously around Severnaya Zemlya since January, but in the last week or two it's kind of like burst out, and I think a rift has opened up in the seafloor, and we have a constant spewing up of these high levels of methane, and that dark brown this range is between 2160 to 10,000 parts per billion, this dark brown. And so it can be anywhere in that range. We don't know what it is, but it's a lot. So we've got that going on. We've got it coming up over here in the East Siberia Sea. We've got it coming up. It's really filling back up all the way across Russia, and when I run the movie, you're going to see it moving out from the land out over the Laptev Sea, and the Scandinavian countries in northwest Russia is totally engulfed with super high levels of methane. You're going to see that moving up and out. We also have a problem area here in the North Atlantic. You'll see that popping off. We've been seeing it pop off on Iceland at certain times in the last couple of weeks. We've seen it popping off on Ellesmere Island in Canada, and in the last few days I've seen it coming up on this east coast of Greenland. So it's really, the Arctic is coming back to life with methane. So let's run the movie and see what we can see here. Now, a lot of these areas where it's coming up out of the ocean is where there is no ice. The sea ice has melted all around these coastlines. But when it moves on up closer to the North Pole, it's coming up through the sea ice. And it's been doing that. See, here we can see off the coast of Greenland, it's popping up. Here it is popping up on Iceland. Okay, watch here. See the yellow and the light green? This is higher release of methane. So here it comes, and it kind of goes through this cycle. It cycles out, and then by Wednesday and Thursday of each week we have another big release. I don't know why that is. Okay, watch this wave move out. See, that's moving out across the Laptev area. We're also seeing higher reading off of northeast Canada here, and it's filling up, going across Canada, and so on. You see this green, the green waves, that's methane. Just the waves are moving out. And the background color, especially on this eastern side where Russia and China and Europe are, it's almost all some kind of green. So depending on the shade of green, it can be like this dark green is about 1920 parts per billion, and this brighter green is 1980, and this chartreuse color is 2000. That's where it moves into 2000 parts per billion. Then it just keeps going up. So a lot of it is at least 2,000 parts per billion background. Okay, now we'll take a peek at the North Pole view. We have an opportunity to see the whole northern hemisphere from this view. That's why I like it. So we're seeing Europe fill back up, Germany especially. It's coming back to life, the UK. And here's the Persian Gulf. I've seen it worse, but it's still bad. Here's India. We can see it starting to creep out over the coastline, coming up through the ocean now. That's what happens as these methane levels go higher and higher. It's not just contained, these high readings are not just contained to the land areas, as we can see up here in the Arctic. Here's China. Okay, and okay, over here in North America and the US, it's filling up from about the Midwest over east, and we can see the green is going further south, filling up down through Texas. California has high readings. That's kind of always. Here in Mexico, that's from the volcanoes going off and earthquakes and things. And a lot of this is from society and pollution. Just a heat engine, the heat engine. If you're new to my channel and you'd like to see some background videos on this stuff, in the description box below the video I have my first videos that I made where I was looking at methane and sulfur dioxide and ozone and some different things, and where I go into explanation as I'm exploring it. And this is my third year. I've started into my third year of doing this, so that was in 2018. April of 2018 is when I did my first one. And this is what I do now. I'm captivated by watching everything, and I want to report on it, so this is what I do. So here on the global view, we're seeing, this is the Antarctic down here, and we're seeing releases all around the coastline, and you can see from week to week these lighter colors of blue streaming up and out, and so this is methane, even a higher level of methane even in the southern hemisphere. We're seeing the difference. I remember when they changed this color ledger, and it used to be mainly like aqua down here on the old color ledger, and then they changed it, and where the blue went all the way up, and it was a lot of purple, and it was so dark you couldn't even make out the lines where the continents were, and you couldn't see the continents unless there was methane coming up. But we don't have that problem now, because the methane levels have increased to the point where you can see the outlines of all the continents now. So that's another sign that it's, I know it's not a real scientific explanation, but that's just what I see, and that's what's reflected in these higher colors. Lighter colors is higher readings. We can see Australia's coming back to life, especially on this east side. New Zealand's coming back to life. It's got some high release on that North Island especially. Now let's look at 500 HPA. So here's about halfway up in the atmosphere. This is almost equivalent to the level that we saw in the NOAA data. I refreshed my browser to get the correct color ledger for the 500 HPA, so we can see heavy concentration at this level from northern India all the way across these areas into China. It's really wide here, and some high reading up here in northern Canada. Now if we ran this movie, this would be moving. This cloud would be moving across, but we're seeing more greens dipping down further south. So like I've said in the last few videos, the methane is mixing and distributing throughout the atmosphere, and so we're seeing greens further south, and this aqua is the background color here, and we're seeing oranges and yellows further south now. Those used to be up here, now they're moving further south. Here's total column, and I'll refresh so we get the correct color ledger. If you don't refresh and you change from one level to the next, it keeps the old color ledger. So this dark area is between 1920 to 2320 parts per billion. So this is all the methane added up through the layers. That's what total column is. Here we can see high concentration in India again, and here over eastern China. And here, this is the Persian Gulf, and it's spreading out. The red is spreading out across Saudi Arabia and Iran, and moving out to the Red Sea. And then the next color is the red-orange, so that will be going red. That area will be going red next. I'm going to go back to my slideshow. I do daily screenshots of things I want to remember from camps, and then I do that in my daily videos too. Sometimes I include them in my weekly updates if I don't want it to go real long, but I'm going to include them today. This is from CAMS, the website we were just looking at. This is the dust from today. Here's the Sahara dust, and I've been tracking all of this dust coming across the Atlantic. So here's the next wave coming over. Here's the one we were just tracking, and it's getting caught up in that Hurricane Isaias. So here's another one that's formed and ready to hit, and it's like this never-ending wave of dust moving to the west and also moving east across this whole eastern tropic area. That it would be difficult. This is the smoke in the Arctic. This is the Arctic view. This is smoke. And this is from the Siberian wildfires that are burning. And then the gray is also smoke. It had blown all the way over and filled up Alaska, and we're seeing it a lot in Canada now. They usually have some wildfires going too. We can also see smoke around this coastline of the Kara Sea. This is the North Pole view. This is sulfates. So we've been seeing a huge sulfur dioxide release in the South Pacific from the Nishinoshima volcano. It's a Japanese island. It's been going off since June 19th, and it's still spewing up, and so this is what, and then it mixes up in the atmosphere and comes across the Pacific. So this sulfate is from China. This is from pollution, and this is from India. That's from pollution. This is from Popocatépetl in Mexico. That's a volcano. Here's the total aerosols in particulates that you're breathing in all around the planet. That includes smoke and dust and sea salt and sulfates. This is the ozone hole over the Arctic right now. This green area, we can see it's getting bigger. And this is not good for the sea ice because there's more radiation coming through from the sun and absorbing and heating up the water. And we've been seeing a hole up here for a while now, and we can see it's quite thin over Canada as well. Here's the global view of the ozone. We can see all the green. That's quite thin. We can see a lot of green around the middle of the planet, and then goes down into the bluish green and then aqua down here over the South Pole. So we've got a disintegration of the ozone layer going on, and not much red where it would be thicker to even out where it's gotten so thin. Here's the South Pole view of the ozone, and so this is the thinnest here over the eastern part. This is north, south, east, west. Here's the Ross Sea, Ross Ice Shelf here. Here in the South Atlantic, we've got a big ozone hole there, and here over the Western Peninsula, it's quite thin, and here on this southern part. Now we'll look at sulfur dioxide. I've been tracking this closely for over a year. I'm very interested in it, and this is the global view on CAMS, total column for today. We can see this huge high reading here in the West Pacific. Here's Japan, and so we've got a big new release. This is where that volcano is, but we've had some really big earthquakes down here on this ring of fire in the last few days as well. Now down here in Mexico, Popocatépetl and Fuego, we've had some extra sulfur dioxide, and we've had some extra release here in the Pacific Ocean, I'm thinking from the Cocos Plate that's moving. Here it is at 500 HPA. I have found that when we have a sudden blast or a sudden burst, like from a volcano or an earthquake, it shoots up past the surface level, and we can see it register quite high at 500 HPA, and that's a sign of volcanic or earthquake activity when we see high readings like that. Here's the East Tropic view, and so we can see the kind of like shock waves going out. That's from a blast, the force of a blast. And then we've got higher readings on land here at China and India and Saudi Arabia and these areas. This is all from pollution. Most of that's from pollution. Here it is at 500 HPA. Now it looks like we've got 2 or 3 different sources. I'm going to zoom in here. Of the sulfur dioxide, there's a large reading here and a big one here. So this Nishinoshima volcano is about down here, and then when it blows up, it shoots up. Not exactly over the volcano, because it, depending on the wind, it can go east or west with a big plume, or any direction. It doesn't have to be straight up. So we can see high levels all around there. Here's the Pacific view. Now the Ring of Fire, if you can visualize the earthquake map with the tectonic plates coming all the way around here and down. This is the Ring of Fire that we're watching. And this is where we have the most sulfur dioxide. Here it is at 500 HPA. Now look at Mexico. We've got a lot of different stuff going on here. Here's the Central America view. So this is from Popocatépetl, and notice we've got release spread out over the Pacific. I think it's more than just from that volcano. Here it is at 500 HPA. So here's Popocatépetl. Here's another concentration here in western Mexico, and then another one here in the Pacific. So what I've noticed is, before we have a large earthquake, a lot of times we'll see a burst of sulfur dioxide come up, and that can be an indicator that we're going to have a large earthquake in that area, if it's not related to volcanic activity. So when we see it like this, we can say, okay, this is volcano, this could be volcano, or it could be earthquake, and this one could be earthquake. The fault line runs right down through here. Here's the North Pole view. This higher reading here in Siberia is from the fires. Here, Alaska, we always see a higher reading in southern Alaska, especially because of the earthquakes releasing. And there are a lot of volcanoes down there too. Here it is at 500 HPA. Here's the South Pole view and 500 HPA. And I took some pictures of earthquakes. These are ones I take pictures of every day that I'm just tracking. Here in Southern California, this is the Searles Valley Ridgecrest area and Lone Pine. And there were 25 here today out of 288 worldwide. This is western Nevada. We've had this swarming going on for a couple of months now. There was I think the highest was a 6.5 near Tonopah. And ever since then it's been swarming, so I'm keeping track of that. And then this is the Mammoth Lakes area in California. This is Bodie. This is all connected. This is Mammoth Lakes is part of the Long Valley super caldera, and the largest earthquake we've had the last 24 hours here is this 3.2 near Bodie, and there are 79 earthquakes in this view. And I live in Reno, Nevada, and this is Pyramid Lake just north of Reno, about 30 miles. And there were 2 earthquakes up here at Pyramid Lake, 1.1 and a 1.6. So I got those, and then they kept having earthquakes up here. This was all this morning. Then they had a 1.8, so that made 3. And then there was a 2.8, this larger dot right there, and that came in. So now there are 4 up there. This started at 2:57 this morning, so Pyramid Lake is shaking. So the 2.8 came in at 9:42 this morning. And those are all my pictures. Now let's move on to sea ice. So my last report was last Sunday, July 26th, for my weekly report. This is what it looked like. This is from Climate Reanalyzer, sea ice and snow cover from last Sunday. Now on this model it's showing a hole opening up just north of Greenland and a hole opening up here in the Chukchi Sea. And someone commented saying that they couldn't find the hole on NASA Worldview. Now that's a different model, and you know they take these pictures at different times of the day, and sometimes the water from the ocean can just close it up, and so it depends on when the picture is taken. So if you didn't see a hole correlating to that on NASA Worldview, I wouldn't worry about it. This is an indication. So this was last Sunday, so I'm going to click through slowly. Here it was on the 27th. That's a big change, and we can see a big thinning on this east side here. Went in, and we had the Arctic cyclone on this west side in Beaufort Sea this week, and I've been tracking that and reporting on it daily for my Subscribe Star members. And here on Tuesday, this is what it looked like. Here's Wednesday the 29th. Here's Thursday the 30th. Here's Friday the 31st. Here's Saturday the 1st. And here it is today. So the cyclone has dissipated and moved down and over the Greenland coast. And I saw a model where it may move back out and it won't be as destructive as a storm, but it's made me back out with some more rain coming back out across. So we can look at that as well. So that's where we are right now with sea ice and snow cover, and the darker areas where it's less concentrated. So it's quite a bit thinner over here in the Beaufort Sea now. This is from the Navy, U.S. Navy Sea Ice Thickness. I follow their website and I report on this every day. This is where we are today with the Arctic sea ice thickness. When we blow it up, this is what it looks like. We can see all the Russia coastline is clear. It's clear around the Alaska and Canadian coastline along here. It's clear on a lot of this Canadian coastline on the islands here, and it's pulling away from the Greenland coastline. And this purple, the dark purple, is about 1 kilometer deep, and I mean 1 meter, not kilometer, 1 meter deep or thick, and then the light purple is about 0.5 meter, and then it keeps getting lighter and lighter as it gets thinner. When it's white, it's just like a little skim of ice. Now, when they're measuring sea ice extent, they count every little tiny little anything. It can just be a little skim, like pond scum. You could just run your finger on it and it would come up. But they count that as sea ice extent. But it's, it's not really much of anything when it gets down to that white. So here's where we are. The dark blue is about 1.25 meters thick. Yeah. And the light aqua is about 2 meters thick, and then the dark aqua is about, 1.5 meters thick. So as it's thinning, it's moving in, and it's getting less and less and less. So this is what's left of the thickest sea ice here. This is what we're heading into August with. Now the sea ice will continue to melt. Traditionally until about September 20th, when the sun starts going down up there. So let's blow this up. So this is the 30-day animation. It uses the data back for 3 weeks, and then it forecasts out 1 week from today. So it goes to August the 9th. It starts on July 11th. So here it is. And stop it. Okay, there it is on the last day. August the 9th. That's where they're anticipating it will be a week from now. We can see white and clear area around northern Greenland here. The Baffin Bay is clear. These little tributaries are almost all clear. And it's just moving in a little bit more and getting thinner. You can see whitish. We still have some sea ice in these quadrants. I've named them 1, 2, 3, and 4, but it's dwindling. So that's where we're at. And you see some white areas over here in the Beaufort Sea. This will open up. Now the pattern of the ice is different this year than from last year. Last year the Beaufort Sea opened up early and we still had ice along the Russia coastline further on into the season. So it's unusual to see all of this ice-free this early in the season. So those are all those pictures. Now let's move on. I want to we'll just tour through Climate Reanalyzer. Here's the temperature for today at 2 meters. The green is above 0 Celsius. We can see most of the Arctic is above the green, or green above blue. The blue is at 0. And here's the flat view of the Earth. We can see a lot of areas that are 40 to 50 degrees Celsius. Here's the 2 meter temperature anomaly, and we can see it's brown. It looks like another heat wave is setting up around the Siberia coastline here and moving out across the Arctic, and it's brown and red here in northern Canada. Here's the flat view. It's coming back. It's getting back into the red and brown, which is hotter than normal in the Antarctic. We have a lot of blues though, which is cooler than normal, and that's what you have when you have abrupt climate change. You have areas where you have really warm air with really cooler air that's colliding, and that's what causes the extreme weather. So overall, worldwide, we're up 0.3 C higher than normal. They're using their baseline from 1979 to 2000. So this is higher than what they would normally see in those years. So the northern hemisphere is up 0.9 C. The Arctic is up 2.1 C. The tropics are up 0.5 C, the southern hemisphere is down 0.3 C, and the Antarctic is down 3.3 C. Here's precipitation and clouds for today. So we can see a little bit of rain and snow coming up here. So like I said, this system moved down over the Canadian coast. But we have another system that I'm very interested in that had been over Iceland, and now it's moving up over this east coast of Greenland, and it's raining. And so that's not good for their ice sheet. That will melt that ice sheet real quickly. Here's the flat view. Here's sea level pressure for today. So we can see the low has moved over to north of Ellesmere Island there. And it's it's like I can't tell what it is. 998. What's what it looks like to me. It's not super low. Here is the jet stream. It's hard to really see it where it's weaker, but it's broken up. It's broken up, and it's not well. It's much stronger in the southern hemisphere than the northern hemisphere, but we can see it's just totally chaotic. So it's hard to predict anything. It's like that. I just showed the sea ice and snow cover. Here's sea surface temperature anomaly. This is for yesterday. As the Arctic Ocean absorbs this radiation from the sun, especially with the ozone hole up there, it's heating up the water, and so we can see we're into the reds and the pinks in a lot of this Arctic Ocean, which is 5 and 6 degrees higher than normal, and probably more than that. It's probably off the chart, and at least brown 2C and up higher than normal all around the ice. And this is because it's not reflecting the heat of the sun, it's absorbing it. Also in the Baffin Bay we can see that it's very high. And remember, there are methane deposits in the sediments in the seafloor all around in the Arctic and up beside Greenland, and in many oceans, in most oceans you'll have methane deposits. But the problem is up here around these coastlines, it's not very deep, and so those methane clathrates can start melting and be released easily, and that's what I think we're seeing around Severnae Zemlya right there that we've been seeing. I think a rift has opened up. Okay, here's the flat view of the sea surface temperature anomaly. We can see most of the oceans are in the brown and higher. So overall, worldwide, we're up 0.5 C higher than normal. The northern hemisphere is up 1 C. The North Atlantic is up 0.9 C. The North Pacific is up 0.9 C. The southern hemisphere is up 0.1 C. The equatorial Pacific is up 0.2 C. And it's only August. The beginning of August. Now here's the National Snow and Ice Data Center. This is the sea ice concentration. This is as of yesterday. This is the blue marble view, and they use a blue scale where if it's white, it's totally concentrated. We don't see any areas that are fully concentrated, and the darker blue it gets, the less concentration you have. So you can see it's a lot less concentrated from, you can see the dark blue, large areas where it's a lot less concentrated. That correlates to what we saw on the Navy website as well. Here's the Arctic sea ice extent. This is area of ocean with at least 15% sea ice, including the little pond scum that I showed you. And they're a little bit behind on tracking. It looks like mid-July, and the blue line is this year, and it's still below the 2012 reading. So we're below 2012, and that was the record low. So that's been the measuring stick, and so we're still below that for this time of year. Here's the Greenland Ice Sheet. This is from National Snow and Ice Data Center. The salmon color is where it's melting today. We have heavy melting down on the southwest edge of the sheet. And as this melts, it flows out into the ocean. It causes sea level rise and also changes the temperature and the salinity of the ocean. It also changes the weight on the tectonic plates, and then we can have isostatic rebound and earthquakes happen. This is the cumulative melt data all year from January through August 1st, and it goes up the colors. So the more colors, we can get into like the orange and red. That's more days that you've had of melting. Here's their chart for the melt extent. The red line is for this year. We can see that it's been melting exponentially, but now it's scooted back down into the median in mid-July. The blue line is mid-July. It's the median. So there's that. Now let's look at NASA Worldview. I will refresh to get the most recent data. This is the Arctic. Let me turn on the blue marble layer. This cuts out the clouds. This is the sea ice concentration level layer that I've got turned on. So here's Greenland, here's the North Pole, here's Novaya Zemlya. This is all Russia up here. Here's Alaska and Canada. So the reds or the pink is where it's just started to melt, and or it's not, is more concentrated, and when you go down to the red, that's less concentrated, and then down through the colors of the rainbow you can see the degrees of melting that's been taking place. And so we're seeing it thinning out here a lot on this western side. That's as a result of that cyclone. And also it's been melting. What can I say? So let's go back to we'll go back to the 26th, which was my report last week. Here's where it was last week. That's what it was. Yeah, it's 26th. Here's where we were last Sunday, and the cyclone was moving across. We had heavy melt down here in the Beaufort Sea at that point. So I'm going to go through slowly. Here's the 27th. You can see it bursting here. Here's the 28th, 29th. Here's the 30th. Big bursting on the 30th. Here's the 31st. Here's the 1st. And here it is today. I'll turn turn the clouds back on and turn that layer off, and this is what we've got. It's very cloudy. It's quite smoky. You can see the smoke over Canada here. And over Russia, it's still smoky, and the smoke is mixing in with the clouds too. And here's the eastern side of the ice edge. We can zoom in, and we've got a pretty good view of this ice edge here. Here's Svalbard. There's the ice. There's Franz Josef Land. Here's Severnaya Zemlya. This is where we see on cams that high release of methane that's been coming up along here. If we zoom in, this is the Volvolov ice cap, and you can see the ice pouring into the ocean here. It's pouring. So it's pretty chaotic looking up here right now. Hard to see much of anything. Here's Greenland. We can look at that coastline. Here's where the ice is, big area where it's open water there. Here's a cloud we can't really see. This is all cloud covered. Here's where we can peek through and see where the ice is broken up. Here we can get a pretty good view. This is broken up. Large areas that's ice free. We've got a thin layer of clouds we're looking through here. Then this is the Beaufort Sea, and here's the Chukchi Sea, and here's the Bering Strait. So that's where we're at with that. I wanted to run one more thing. Wanted to show you. I've been doing this periodically for my Subscribestar members. I've been running the model for the Arctic so we could see precipitation and pressure. We could see what's going to be going on. This is a 10-day a 10-day model, and so here we are on August the 2nd. So this is what we've got right now. So this is where the cyclone ended up, down here, coming down over Canada, and now it's snowing there, and it's sea level pressure is 999 there. We have another system up here where it's raining. This is right around the North Pole, and it's raining and snowing. It's not real low. It's only 1,000 millibars. Got a high pressure system setting up in the Beaufort Sea, and it's raining on this Alaska and Canada coastline. So that's what it's doing right now. And then here's this system from Iceland that's coming up and raining along the Greenland coastline. So let's run this, and we can see what's going to happen for the next 10 days. So it looks like Greenland is going to get a lot of rain, and then the rain is moving on up. And then we've got another system coming down with rain from Siberia. It doesn't look like another cyclone though. It's not that much of a low pressure. So there we are. So it goes through the 12th, then starts over. So we do have a system here that's moving up towards the Siberia coastline. And then rain here. So that's kind of what we've got. I'm going to stop that. Okay, now I want to, here's Earth Null School. I've been tracking that cyclone up here, and we can see it's fizzled out. So here's that system up north that's moving up. I wanted to show, though, I wanted to show the jet stream. This is 250 HPA. It's a little easier to see here on Earth Null School. Look how crazy it is. There's no rhyme or reason to it. See the loops? It's looping way up high and then goes way down and way back up. Here's the southern hemisphere. It's much stronger here in the southern hemisphere, but it's looping and broken up down here too. So this is chaos. The jet stream is breaking up. So I just wanted to show that. Now, I know this is getting kind of long. I just want to briefly look at some earthquakes. This is USGS for all magnitudes for the last 24 hours. We've had some big ones down here at Papua New Guinea. We've had 5.8, 5.3, and then a 5.0 in Indonesia. These are 4s. This is 5.7 Vanuatu. These are 4s down here in Indonesia. So the area that we saw the big thing of sulfur dioxide is down here in the South Pacific, and see this plate line runs along here. So when the plates move, the sulfur dioxide can be released if there's a big pocket, in addition to the volcano that's going off down there. We're still seeing movement. Here's China, 4.4 at Kashgar, China. I wanted to show here on this Juan de Fuca plate on the West Pacific, the western Northwest Pacific, we've had two on this Juan de Fuca plate today. There was a 3.3 and a 3.3 on this west side of the plate, and then this Cascadia subduction zone is right here along the California coast. So we're seeing activity all the way up and down here. So that's coming back to life. So that's kind of all I wanted to look at on earthquakes. Now I'd like to end with a Bible reading, and I'm going to take a break from the prophetic books of the Bible, and I like Psalms 23. A lot of people know this one, and it's one that if you're afraid or just needing some comfort, this is one that I like, a Psalm of David. The Lord is my shepherd, I shall not want. He maketh me to lie down in green pastures. He leadeth me beside the still waters. He restoreth my soul. He leadeth me in the paths of righteousness for his name's sake. Yea, though I walk through the valley of the shadow of death, I shall fear no evil. For thou art with me. Thy rod and thy staff, they comfort me. Thou preparest a table before me in the presence of mine enemies. Thou anointest my head with oil. My cup runneth over. Surely goodness and mercy shall follow me all the days of my life, and I will dwell in the house of the Lord forever. So I do think we are in the end times. I've been called to do this work, to be a watch person on the wall, and to report what I see and to warn people of what I see coming. And what I see is, I feel like the end is near, and if you haven't gotten your spiritual house in order, I recommend you do it now. And if you haven't given your life to Jesus Christ, I recommend you do it now and repent and get right with God and Jesus before the end is here. So I love you all, and until next time, I'm praying for everyone. So God bless you, go in peace, and I will talk to you soon. Goodbye.